There exists a terrifying truth behind our planet. On a regular basis, even without our help, planet Earth likes to kill almost all living things on it. One example is the Toba Catastrophe, a volcanic eruption so massive it nearly wiped out humanity. Join us as we explore the evidence, the consequences, and the chilling possibility of it happening again. From the geological record to the genetic evidence, we're giving you scientific proof that supports the Toba Catastrophe theory. We'll learn how scientists uncovered the devastating impact this event had on our planet and its inhabitants. This sort of apocalyptic tragedy is a huge problem that society obsesses about today in the form of disaster movies and video games like Fallout. The obsession extends to popular estimates that there may have been as few as 1,000 humans in the past, which we'll find out later whether it's true or false. We'll also explore the potential future implications of a similar catastrophe and discuss what we can do to prepare and mitigate its risks. This fascinating journey of discovery starts now. The Toba volcanic eruption was a catastrophic event that occurred approximately 75,000 years ago. It was one of the largest volcanic eruptions in the last 2 million years, with an estimated volcanic explosivity index of 8. This means it was at least 10,000 times more powerful than the 1980 eruption of Mount St. Helens. The Toba volcanic eruption also happens to be one of the most well-documented volcanic events in Earth's history. There is a wealth of evidence supporting its occurrence. The most direct evidence comes from the geological record. Deposits of volcanic ash and debris from the eruption have been found across Southeast Asia, including Indonesia, Malaysia, India, and China. These deposits provide a clear indication of the eruption's magnitude and extent. Ice cores from Antarctica and Greenland contain layers of volcanic ash that correspond to the Toba eruption. These layers provide information about the timing and intensity of the eruption. Marine sediment cores also contain evidence of the Toba eruption, such as changes in the concentration of volcanic glass and other volcanic debris. So what were the consequences of this violent eruption? The eruption released an enormous amount of ash and debris into the atmosphere, which caused a global volcanic winter that lasted for several years. This winter led to a significant decrease in global temperatures and reduced sunlight, which disrupted food chains and even affected human populations. Some scientists believe that the Toba eruption may have caused a population bottleneck in humans, reducing the global population to a few thousand individuals. This theory is supported by genetic evidence, which suggests a significant decrease in genetic diversity around this time. A genetic bottleneck occurs when a population is drastically reduced in size, leading to a loss of genetic diversity. This can happen due to various factors, including natural disasters, disease, or migration. In the case of the Toba catastrophe, the global cooling and environmental changes it caused may have led to a significant decline in human populations. If a genetic bottleneck did occur, it would have had a profound impact on the genetic makeup of modern humans. The reduced population size would have limited the number of genetic variations available to the next generation, potentially leading to a loss of genetic diversity. So what are the implications for modern humans and our society today? The genetic bottleneck caused by the Toba catastrophe may have several implications for modern humans. Modern humans may have a relatively low level of genetic diversity compared to other species. This could make us more susceptible to certain diseases and genetic disorders. A reduced genetic diversity could also limit our ability to adapt to changing environmental conditions. For example, if a new disease emerges, a population with low genetic diversity may be less likely to have individuals with natural resistance. Finally, the Toba catastrophe may have led to the formation of very distinct human populations, such as the ancestors of modern Africans, Europeans, and Asians. These populations may have evolved in isolation, leading to the development of unique genetic traits. This devastating volcanic event, therefore, may help us understand how artificial any biological distinctions between each of these groups may be. The few differences that exist, such as skin color or disposition towards sickness, occur due to chance. Africans may look very different from Native Americans, for example, but monstrous geological changes in our Earth were a contributing factor. While the exact impact of the Toba catastrophe on human genetics is still being debated, it's clear that this event was a significant milestone in our evolutionary history. Controversially, some sources will claim that only 1,000 humans existed at one time because of this event. However, there is no scientific evidence to support the claim that there were ever only as few as 1,000 human beings left alive at any point in global history. We know based on evidence that a reasonable number is actually anywhere from less than 10,000 to much more than 1,000. But here is a scary question. Will a disastrous volcanic eruption such as this ever happen again? The truth is that it is possible that another volcanic eruption similar to the Toba catastrophe could occur in the future. While such events are rare, they're not impossible. There are several active volcanoes around the world that have the potential to produce large-scale eruptions. Some of these include the Yellowstone caldera, This supervolcano in the United States is capable of producing a massive eruption that could have global consequences. The last major eruption of the Yellowstone supervolcano was approximately 640,000 years ago. However, there have been smaller eruptions and hydrothermal activity in the park since then. The Taupo volcano, located in New Zealand, Taupo is another supervolcano that has the potential for a catastrophic eruption, as it could potentially spew megatons of pyroclastic material and ash high into the atmosphere. The last major eruption of the Taupo volcano occurred approximately 1800 years ago. This eruption, known as the Hatepe or Taupo eruption, was one of the most powerful volcanic events in the world in the last 5,000 years. Icelandic volcanoes can also pose a significant risk to global extinction events. Iceland is located in the Mid-Atlantic Ridge, a region of intense volcanic activity that has already interfered with air travel in recent history. The most recent eruption of an Icelandic volcano that significantly interfered with air travel was in 2010. When this volcano erupted, it spewed ash clouds into the atmosphere that disrupted air traffic across Europe for several days. This disruption caused widespread travel chaos and economic losses. Finally, there are the Phlegraean fields. This volcanic complex near Naples, Italy, has experienced several large eruptions in the past, such as Pompeii, and remains active today. The eruption of Mount Vesuvius that destroyed Pompeii occurred in 79 AD, and tours of the affected areas are readily available and quite popular with modern tourists. While it's impossible to predict exactly when or where the next major volcanic eruption will occur, the risk of such an event cannot be ignored. Scientists are constantly monitoring volcanoes around the world to try to detect signs of potential eruptions and to develop early warning systems. If a volcanic eruption similar to the Toba Catastrophe were to happen today, it would have a devastating impact on the planet and its inhabitants. However, with advances in technology and early warning systems, it's possible that we could mitigate some of the worst effects of such an event. These worst effects could include ashfall, lava flows, and climate disruption. There are some mitigation efforts that could be implemented to minimize the impact of such an event. Fortunately, we have early warning systems already in place. These continuously monitor volcanoes using seismic sensors, gas monitoring equipment, and satellite imagery to detect signs of an impending eruption. Major industrialized nations also develop and implement evacuation plans for areas at risk, ensuring that residents and tourists can be safely evacuated in a timely manner. Ashfall mitigation is a little more tricky. Governments can provide residents with protective gear such as masks, goggles, and long sleeves to minimize exposure to volcanic ash. However, it would have to be a pretty large expected explosion for this to happen. More likely is that governments will move to protect critical infrastructure, such as power plants, water treatment facilities, and transportation networks from ashfall damage. Agricultural protection is also a little dicey and generally complicated. Authorities would have to implement measures to protect crops and livestock from ashfall, such as covering fields and providing shelter. When volcanoes are mentioned, everyone thinks about lava, but can we really provide lava flow mitigation? Such mitigation may come in the form of diversion channels that guide lava flows away from populated areas. More likely is to imply cooling techniques, such as spraying water on lava flows to slow their advance. In effect, the hardening lava is going to act as a barrier that slows or diverts new lava. And what about our climate? How could we avoid this becoming an extinction-level event? If the eruption causes significant global cooling, governments may consider geoengineering techniques, such as injecting aerosols into the atmosphere to reflect sunlight and counteract the cooling effect. Food security will also become a big problem. This means having geographically available emergency food supplies and active agricultural assistance from the international community. Long-term recovery measures would include rebuilding damaged infrastructure, providing financial assistance and support to help communities recover economically from the disaster, and even measures to restore the affected environment, such as reforestation and soil conservation. It's important to note that the effectiveness of these mitigation efforts will depend on the specific characteristics of the volcanic eruption, such as the type of volcano, the location of the eruption, and the prevailing weather conditions. Where do you think the next major volcanic eruption will take place? Leave a comment about what you think. Also, if you love learning about ancient biology, dinosaurs, and science-based content, make sure to like, comment, and subscribe to Primalia for more satisfying videos. If you think this video is share-worthy, share it with a friend who loves ancient biology as much as we do. It really helps motivate the Primalia team. Stay curious.